You've been factoring a lot of ways, grouping, taking out the GCF, but sometimes there's going to be a binomial that can be factored like that. This is my favorite factoring when I was a kid. I even remember thinking, God, I hope he puts a bunch of these on the test. The difference of two perfect squares would be like number 1, I told you to multiply x plus 4, x minus 4. If you multiply it, you should have got x squared minus 16. Because the middle term disappears when you have one of each. See, 4x, negative 4x, gone. So anytime you see the difference of two perfect squares, you know how to factor it. One's plus, one's minus, just take the square root. Example. Now we did this yesterday, but nobody got it right, remember? X squared minus 9. First thing you always do, is there a GCF? No. This is a perfect square without the sign. This is a perfect square. Take the square root of x, take the square root of 9, one's plus, one's minus. Easiest factoring there is. Okay? Is this the difference of two perfect squares? Yes. Square root of that, 2x. Square root of that, 4. All you knuckleheads are going to do this. 2x plus 4, 2x minus 4. Wrong. Why? You got to do the GCF first. Take out a 4. X squared minus 4. Then check again. Do I have two perfect squares? Yes. Bring down the 4. One's plus, one's minus. X and 2, x and 2. Everybody misses that because they don't do the GCF. GCF is always first. All right, what would this be? A squared minus b squared.
It'd be a plus b and a minus b.
And that's basically the definition of two perfect squares. One's plus, one's minus. After you factor, you can always check it. This will be the hard one. How about 16 x squared minus 49 y squared? First of all, is there a GCF? No. Is this a perfect square?
Yes.
Is that a perfect square?
Yes.
One's plus, one's minus. I always start like that. Square root, 4x. Square root, 7y. One's plus, one's minus. You with me? Yeah. Is this two perfect squares? Yes. Every even exponent is a perfect square. What's x to the 4th times x to the 4th? X to the 8. Plus y. I'm not done. Why? I have it again. There's no GCF.
What? Well, x to the 4, x to the 4th and x to the 4th.
No. This is the difference of two perfect squares. Bring this one down. X to the 4th plus y to the 4th. One's plus, one's minus. Square root, what's the matter? This is not a difference. You can't factor that. What's the square root of that?
X squared.
What's the square root of that?
Y squared.
One's plus, one's minus. Oh, got another one. X to the 4th plus y to the 4th. X squared plus y squared. One's plus, one's minus. Don't stop until you have no perfect squares.
So you just have to keep going.
You have to keep going. What?
Why didn't you do the first term?
Yeah.
What didn't I do? What? This one?
Yeah, because that one
Because
still has
none of them are
two.
supposed
Do
to
you see what I have underlined here?
Yeah.
None of them are supposed to be equal. Remember, look at them. None of them equal to each other. You see that? There's no.
Okay. I know what she's asking. She's asking me, why don't I factor this? Right? Okay. One's plus, one's minus. Is that what you want me to do?
Oh, no.
I'm going to multiply it for you. Is that what I started with?
No.
Something's wrong.
Yeah.
It's the difference of two perfect squares.
So it's only the subtraction ones that you do that?
Difference is subtraction. Okay? You're getting it mixed up with this. That's why we always do it on the same day. Okay? 25 y squared minus 36 y squared. Ah, that's no good. Those are like terms. All you do is subtract a negative. Let's make that a x. All right. Is there a GCF? No. One's plus, one's minus. 5x, 6y. See, when one's plus and one's minus, the middle term disappears.
So why don't you change that?
Change what?
Because
This equals this.
so how did that last one? Why?
Because it was plus. Okay, you got plus. How is the middle term going to disappear? It's not. Okay? Now, what happens... All right, two perfect squares. One's plus, one's minus. X to the fourth plus 1, x to the fourth minus 1. Two perfect squares. One's plus, one's minus. Two perfect squares. One's plus, one's minus. Everybody misses this one. If they factor and this is the problem that was on the test last year, and everybody left it as this. They didn't take it one more step. Always check, do I have two perfect squares, and is it subtraction? Okay? All right? I should probably do two videos, one on this and one on the perfect square trinomials. Perfect squares?
Yes.
One's plus, one's minus. 4x squared and 1. 4x squared and 1. Two perfect squares. See, all I'm doing is bringing that one down. That's already part of the answer, like pulling out a GCF. One's plus, one's minus. Do I have two perfect squares?
Yeah.
No. Square root of 2? Do I have two perfect squares?
Yeah.
I do. All even exponents are perfect squares when you have a variable. Okay? One's plus, one's minus. X to the third, y to the fourth. No. Okay, ready for a hard one?
No.
Too bad. Do I have two perfect squares? I do. Square root of 1 is 1. Square root of 4x squared is 2x. But something's wrong with this. It's not in the correct order. So, negative 4x squared, positive 1. Should I stop? It's not a difference anymore.
No.
What should I do?
Take out the negative.
Take out the negative. 4x squared minus 1. Now I have two perfect squares again. And it's subtraction. One's plus, one's minus. 2x and 1, 2x and 1. What's the matter? First I wrote it in order. Then I took out a leading coefficient, that's negative. Then I ended up with the difference of two perfect squares. Didn't I?
Yes.
Anytime you have a difference of two perfect squares, one's plus, one's minus, take the square root. Yeah, there's a lot to remember. Yeah. A lot to remember. One more of these and then I'm going to move on to the hard part. Yeah, that was the easy part. Two perfect squares?
No.
Why not?
Because the
odd.
There's the problem. Now if that was a 6, we could move on. One's plus, one's minus, 4x, y cubed. Done. Now here's the kind you'll miss. It's two perfect squares.
Greatest common
Feel
factor.
why?
You have a GCF.
4 on the outside, then it's y squared.
4. 4x squared minus,
Y squared. Y squared.
oh yeah, minus y squared. Now, two perfect squares. One's plus, one's minus.
2x.
2x, y, y. There's a lot to remember, and I have a sheet today that says choosing a factoring method. How much time do I have?
You're at like 12 minutes.
Okay, perfect. I'm going to go over this, and then I'm going to do another video of the hard part, which is a perfect square trinomial. All right. I'm giving you a sheet that tells you exactly the order you should do things from now on, now that you're going to have these two special cases. Order number 1, greatest common, put them in order. Okay?
What do you do if you have a...
Wait, I'm giving you the whole order. Hang on. We're on video. First, make sure it's in standard form. Next, make sure you take out the greatest common factor. That's the key to most people missing their questions. Next, do you have a difference of two perfect squares? If you don't, next, do you have a trinomial that is a perfect square? That's the lesson coming up. Now you go to what you've been doing. Do you have a trinomial that is not a perfect square? Then you either factor it the shortcut way, because you already have the GCF out, or you factor it by grouping. And then finally, if it's 4 terms and there's no GCF, you are grouping. Okay, all written out step by step with examples. You might try reading my notes once in a while. They really do help. So I'm told.